Hello folks, welcome to the part 4 video of this exercise 1.2 and we'll be seeing the upcoming problems. The problem number 5 says that you are having a function f of x which is defined as f of x as 1 for all x positive. It is defined as 0 when x is 0 and is defined as minus 1 when x is less than 0. So it is neither 1 to 1 or on to, it is neither 1 to 1 on or on to, so we've got to give an example, we have to give counter examples for that. So let us understand this function first pictorially so that it's easy for us to get the values. You are from reals to reals, I suppose. Yeah, we are from real to real. F is from real number to real number, so we can have anything. We can have minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Of course, we have so many values, we just picked up some values. Now, my negatives are all going to minus 1. So, all these negatives will go to minus 1. 0 will go to 0 and the positives will all go to 1. That's how the function is defined. So, it's very clear to us, many of them going to 1. So, it cannot be 1 to 1 and only minus 1, 0 and 1 related. So in the real number there are so many other unrelated elements. That is why it is not onto. So let's look for 1 to 1. For 1 to 1 we can have it directly from here. F of minus 1 is minus 1. You can take many examples. F of minus 2 is also minus 1. Therefore minus 1 minus 2 has the same image 1 minus 1, therefore f is not 1 to 1, right? Then on to, okay, for on to here there are so many other elements in real numbers. For example, if you can take 2, there is a 2 here, it has got no pre-image, right? So for 2 belonging to real numbers codomain, there does not exist x belonging to R domain such that f of x is 2. You don't have any element that is related to 2 here. You have only pre-images for minus 1, 1 and 0, right? That is why it's not on 2. So that's about this. It's called as a signum function. I think it's given in the textbook also. Let's quickly move to the next question. The next question says that you are taking a function from the set 1, 2, 3 to the function 4, 5, 6, 7. The function is defined as they have given us. You have to say that, you have to check whether it is 1 to 1. Again, we can plot this so that it makes things very clear. From 1, 2 and 3 which is A to 4, 5, 6, 7 which is B. Yeah, we have 1 going to 4. You have 2 going to 5 and you have 3 going to 6. Whether it is 1 to 1, yes, 1 is going to 1, 1 is going to 1, 1 is going to 1. So it is 1 to 1. And had they asked us onto, it wouldn't be onto. Why? Because the 7 is unrelated. It doesn't have a pre-image. But they have not asked onto. 1 to 1 it is. So we can write here f of 1 is 4, f of 2 is 5 and f of 3 is 6. So for x1 not equal to x2, f of x1 is also not equal to f of x2, right? The f values are not also same, the x values are also not same. So therefore f is 1 to 1, right? So that's how we are saying that it is 1 to 1. Right, then we have this question number 7, part number 1, where the question number 7 they say that you have to check. Nothing has been told, it's check. Now one more thing, the functions which are both 1 to 1 and on to 2 is called as bijective. When they are injective and surjective together, it becomes bijective. So to check whether they are bijective, they should be bijective. Okay, so let's see how. So first for 1 to 1. Polynomial functions generally will be okay, right? So for 1 to 1, let f of x1 be equal to f of x2. So what will happen? 3 minus 4x1 equal to 3 minus 4x2. Subtracting 3 on both sides, you will get minus 4x1 equal to minus 4x2. Minuses can cancel. dividing by 4, we will get x1 to be equal to x2. So what happens? Thus, starting with f of x1 equal to f of x2, you are getting x1 equal to x2. Therefore, f is 1 to 1. Then, onto. Okay, for onto, what we do is we will have an element. The function is defined from R to R. See, for onto, what will happen is we will take any one point over here in R. You should know from which x is it coming. Okay, should know its pre-image. So that's what we're going to do. Let y belong to R. So our y is belonging here. For y belonging to R, there exists some element R codomain. There exists some element belonging to R domain. Okay, now we will find that. Now how to find that is a trick. What we do is we will call y equal to this 3 minus 4x, because apparently this x is what is landing up into 3 minus 4x. So we will kind of equate this y equal to 3 minus 4x and try to see what x is coming up like. So we shift terms. Minus 4x, let it come here. Let the 3 go there. So it is y minus 3. Then we will have the divided by minus 4. So you would have probably 3 minus y by 4. So actually, if you could have a y over here, there exists 3 minus y by 4 belonging to R, such that you take f of 3 minus y by 4. Let's find out what it is coming to by definition. What is the definition of f? It is 3 minus 4 into whatever is there in the bracket, 3 minus y by 4. How can we solve it? 4 first of all cancels. 3 minus y. 3 minus 3 plus y. Cancel. Y. So what is happening? This element, it is kind of f of x equal to y. We have reached to y. Therefore, f is onto. So for a general function, this is what we do. We look out for that particular term, equate it to the polynomial given to us. It's a trick. And then find out which is the pre-image. Now this is a very effective tool. It can be, suppose if there's somebody who tells me, come on, there is a 5 here, you tell me from which number it is coming. It's very easy for me to find out. If they tell me, come on, 5 belongs to the codomain, you tell me from which pre-image it is coming, I can find out. What I will do is I'll just substitute it here. 3 minus 5 by 4, it is minus 2 by 4 minus half. So it's minus half, f of minus half, which becomes 5. Understood? And how is that? F of minus half, just take f of minus half by definition. It is 3 minus 4 into minus half. So what is coming? 3, 1 minute. I hope I have done everything. 3 minus y by 4. So 3 minus small error is there because it's come to 5, isn't it? 1, wait a second. 3 minus 4x equal to y. 4x equal to 3 minus y by 4. Definition, nothing is wrong. Then for 5 it is 3 minus 5 by 4 minus 2 by 4 minus. Hi, what should go wrong? 3 minus. Okay, so 3 minus 4. Yeah. So this is 2, isn't it? Yeah, smaller. So 3 plus 2, it is 5. I was mistaking that 2 to 1. That's how I was panicking. 5. So it is for 5 belonging to R, We put it in that, we know it is half, and when we did f of minus half, it's coming to 5. So you told me 5, I am able to tell you the pre-image. Why? Because I know this relation. The moment you tell me any element in the codomain, I will tell which is the element in the domain which is going to get related. Okay, and why I'm able to tell? Because I know this relation, right? So that is how it is onto. That's about the ontoness. So now, because they are both onto and one-to-one, therefore f is bijective also. When they are both one-to-one and onto, it will be bijective from 1 and 2. Lack of space, so I'm writing it like that. You could write it freshly down. This is 2 and this is 1. From 1 and 2, f is bijective. Okay, that's about this. Now we'll take the next subpart where they are giving us a function f of x equal to 1 plus x squared, and we have to show whether it is bijective. Now fortunately or unfortunately, that's not bijective because it's not 1 to 1, it's not onto. Generally the square terms, you have to be a little careful. 9 out of 10 cases it will create trouble, right? So it will not satisfy. So here it's not getting satisfied, and we are just finding counter examples. So let's look at 1 to 1. Let's consider say f of 1. What will it be? 1 plus 1 squared, which is 2. Let's consider f of minus 1. So it is 1 plus minus 1 squared, that's also 2. So 1 and minus 1 has the same image too. So f is not on 1 to 1. Right, because this minus 1 and 1, they both are going to 2. We don't allow that for 1 to 1. So it's not 1 to 1. Then we go for onto. Automatically, if it's not 1 to 1, it's already not bijective. Okay, onto also we'll check. For onto, maybe you could just look at this function for you to understand how these functions are. It's from R to R, if I'm not mistaken. Yes, it's from R to R. Suppose if you have something like minus 3, minus 2, minus 1, 0, 1, 2, 3, for example. Minus 3 squared is 9. 9 plus 1 goes to 10. This is also going to 10. 2 squared is going to 4. 4 plus 1, 5. This is also going to 5. 1, we saw it. It's going to 2. 0 will go to 1. Right. So we have, in a nutshell, these are how the functions are linked. Now the problem is, we see that all positives are only linked. Negatives will not get linked, right? There are negatives which will be left out. So suppose if you take minus 2, so let minus 2 belong to real number codomain. There does not exist, this is a symbol, there does not exist x belonging to our domain such that f of x equal to minus 2. There will not be. And technically you can just say 1 plus x squared, if it has to be minus 2, then x squared has to be minus 2 minus 1 minus 3, which could be the cube root or square root of minus 3. It doesn't happen. So that is why such a thing doesn't exist. We are not able to find, no matter how much points you plot and see, you will not get it. So that's how it doesn't happen, and that is why it is not onto, so it's not bijective. Therefore f is not bijective. That's about this in this video. With more problems in the next video. Thank you.